Hidden surface removal is a problem in rendering images of 3D objects. Several different algorithms are commonly used, and they each have their own benefits and drawbacks. We will show the output of each one separately, and then we will watch them run simultaneously. The first algorithm is Newell and Sanchez algorithm, often called a painter's algorithm, because each polygon in the scene is painted into the frame buffer in its entirety. The algorithm does much of its work before any polygons are scan converted by sorting the polygons in Z order from back to front. What we see now is the algorithm scan converting each sorted polygon into the frame buffer one at a time. Pixels of polygons toward the end of the list that are closer to the viewpoint may be written over pixels in the frame buffer belonging to more distant polygons. The trick is to determine an accurate way to Z-sort polygons. This can be non-trivial if polygons intersect, or if 3 or more polygons are overlapped in such a way that none are clearly in front of the others, like the flaps of a cardboard box woven shut. In the Z-buffer algorithm, polygons are scan converted into 2 buffers instead of just 1. As they are scan converted, the Z value at each pixel is stored into a block of memory called the Z-buffer. The Z-buffer is the same size as the frame buffer, but instead of storing a color value at each pixel, we store the Z value of the polygon closest to the viewpoint. We initialize the Z-buffer to the largest possible Z value, which is either infinity or the backplane of the view volume. As polygons are scan converted, their Z values at each pixel are compared with the values in the Z-buffer at that pixel. If the Z value for a polygon is less than the Z value in the Z-buffer, i.e. the Z value is closer to the viewpoint, we store the new value in the Z-buffer, and we write the color of the new polygon into the frame buffer. Otherwise, the pixel is farther away, so we can continue scan converting without altering the frame buffer. Unlike the painter's algorithm, the Z-buffer algorithm accepts polygons in arbitrary order. It is therefore ideally suited for a simple hardware implementation. The scanline algorithm is an extension of polygon scan conversion that processes many polygons at once instead of just one. Depth comparisons are made at polygon edges to determine which polygon is closest to the viewpoint. Most of the algorithm is similar to the scan conversion algorithm. A complete list of edges is made and sorted on the least Y value of each edge. An active edge list contains all edges which cross the current scan line and is sorted on the edge's current X value. To process a single scan line, we start at the top of the active edge list and move down the list until we reach either another edge of the same polygon or an edge of a polygon that is closer to the viewer than the current polygon. We output the span between the 2 edges in the color of the original polygon, and the new polygon, if there is one, becomes the current polygon. Once we reach the end of the active list, we remove any edges that are no longer active. After we move up to the next line, we start over again, adding edges from the edge list to the active edge list that start at this new line. Now we can compare all 3 algorithms running together. The Z-buffer algorithm starts outputting polygons before either of the other 2 algorithms because there's no pre-processing involved. It spits out polygons as soon as they are read in, but it uses up an additional buffer's worth of memory, typically 16, 24, or 32 bits per pixel. The speed of each algorithm depends on the number of polygons in the scene and their sizes. Both painters and Z-buffer scan convert every polygon that they read in. Z-buffer, however, has no computation overhead, so its execution time will not grow appreciably even for very large numbers of polygons. This is because as the number of polygons increases with scene complexity, the number of pixels per polygon decreases, and the total number of comparisons remains relatively constant. Due to sorting's n log n overhead in the painter's algorithm, running time increases very quickly when the number of polygons in the scene increases, so it's a bad idea to use painters for complex scenes. The scanline algorithm does some pre-processing, but the majority of its work is done while scan converting. Because of this overhead, scanline algorithms tend to be slow, especially when there are many small polygons in a scene. It is also more difficult to code than the other algorithms, but because it works in image space, it can handle transparent surfaces, anti-aliasing, and other important rendering techniques.